All right, so this video is to go over pages 35 and 36 in your workbook. So our notes on solving equations with rational exponents. So you'll see a lot of similarities between solving these rational exponents and when we've been solving our radical, because remember, a rational exponent is simply a radical and an exponent put together. So like x to the 2/3 is really the cubed root of x squared. So it's very similar in the process of solving these rational equations. So we're going to isolate the term with the rational exponent first, then raise each side to the reciprocal. So that's important that we use the reciprocal exponent to eliminate it. One thing we have to notice is that if the reciprocal is an even denominator, then our answer will have a plus or minus. That's because if you remember solving something like x squared equals 4, if we take the square root of both sides, our answer could be plus or minus 2. So the same thing will happen here. If we're taking an even root, we're going to have a plus or minus here. And then we can finish solving and check for extraneous solutions. So if we go ahead and look at number 1, we don't need to isolate. The rational exponent is already by itself. So when it's already by itself, we're then going to take the reciprocal exponent. So the reciprocal of 2/3 is 3/2. So we're going to raise both equations. So x to the 2/3 is going to be raised to the 3/2, as well as 4 is going to be raised to 3/2, right? What you do to one side of the equation, you have to do to the other. What that allows us to do is to cancel out our 2/3 with our 3/2, so it's going to give us a 1, right? If you multiply, power to a power says you multiply these exponents together, so 2/3 times 3/2 is 6/6, which is just 1. So this is x to the first, and then we have 4 to the 3/2, which now we can rewrite this, right? We can, like we did up here, we can rewrite this exponential in radical form, or this exponent in radical form. So then I would have the square root of 4 to the 3rd power. Now remember, I said if you're taking an even root, so since this bottom number is even, right, we're taking an even root, that means we have to have a plus or minus answer. So right here, when I take the square root of 4, this is going to give me plus or minus 2, and then I have to cube that. So if I take positive 2 and I cube it, I get positive 8. If I take negative 2 and I cube it, I get negative 8. So those are my two answers. So here x equals plus or minus 8. So then for our next example, again, the first thing we need to do is to get the radical or the rational exponent by itself. So we would need to add 4 to both sides. So then I have x minus 2 to the 3/2 equals 27. So again, to get rid of 3/2, I'm going to raise both sides to its reciprocal. So the opposite, or the reciprocal of 3/2 is 2/3. So then I have 27 to 2/3 power. So then these cancel or give me 1. So I'm just left with x minus 2. And then 27 to the 2/3 is the cubed root of 27 squared. The cubed root of 27 is 3. It takes 3 3s to get to 27. And then squared would give me 9. So here I get 9. It is an odd root, so I'm only going to get positive 3 here, which means when I square it, I'm only going to get 9 as my answer, right? If I cube root, the idea behind this is if I have x squared equals 4, I can plug in positive 2 or negative 2. If I have x cubed, if I plug in positive 2, I get positive 8. If I plug in negative 2, I get negative 8. So cubes don't give us the same result. So then I just have positive 9. So then to solve for x, I add 2, and I get x equals 11. So if you're feeling comfortable at this point, you can pause the video and try the rest on this page on your own. I am going to go through the next couple just to kind of keep going in case you'd want some more support. So I'm going to look at number 3 and 4 next, but if you want to try them on your own, go ahead and pause the video and do that now. So to solve number 3, again, my goal is to get the x by itself, so I'm going to subtract 6 from both sides. So then I have x to the 3/4 equals 8. So then from there, I'm going to take the reciprocal to get rid of my rational exponent. So I'm going to multiply both sides by 4/3 or raise it to the 4/3 power. So then 3/4 and 4/3 gives me 1 here. And then I have 8 to the 4/3, which is really the cubed root of 8 to the 4th power. So this is an odd root, meaning we're only going to get one answer. The cubed root of 8 is 2, and then 2 to the 4th power would give me 16. So here I get x equals 16. All right, so then looking at number 4, my rational exponent part is already by itself, right? All of this is being raised to the 4/5, so there's nothing else to isolate. So then I'm going to raise this to its reciprocal. So the reciprocal of 4/5 is 5/4. So then that means I'm also raising 16 to the 5/4. So these cancel, giving me x plus 1, and this gives me 16 to the 5/4, which is the 4th root of 16 to the 5th power. So now note, this is an even root, which means I'm going to get a plus and minus answer. So the 4th root of 16, what number do you multiply together 4 times to get 16? That would be 2. So I get plus or minus 2. And then I'm going to raise that to the 5th power. So if I raise positive 2 to the 5th power, I get positive 32. If I raise negative 2 to the 5th power, I get negative 32. So I end up with essentially plus or minus 32. Now here, I have to split this up to solve. I cannot just subtract 1 and get plus or minus 31. That's not how this works. This is 2 separate equations. It's x plus 1 equals 32 and x plus 1 equals negative 32. So that when I solve for x, I'm using the right value. So here I get 31 and negative 33. So then if I want to check for extraneous solutions, I haven't done that yet, I've forgotten, I apologize. But when I check for extraneous solutions, I just want to plug this in and make sure that I actually get the value on the other side. Sometimes, especially with these 2 solutions, one of our signs can be off when we plug this in. So if I plug in 31, I have 31 plus 1 to the 4/5 equals 16. So then I have 32 to the 4/5. So the 5th root of 32 is 2, and 2 to the 4th is 16. So I know that that is true. And then if I do negative 33 plus 1 to the 4th, I get negative 32 to the 4/5. Well, then here the 5th root of negative 32 would be negative 2. And then when I raise that to the 4th, I would also get positive 16. So in this case, that solution would work as well. So let's go ahead. Again, if you feel comfortable, pause the video and just see if you can get the answers on your own. But I'm going to walk through these next ones as well. So again, the first thing we need to isolate this variable. So I'm going to subtract 5 first. So then I have 3x to the 4/3 power equals 48. And then I still need to get the x that's raised to this exponent by itself. So I'm going to divide both sides by 3. So x to the 4/3 equals 16. And now that I have this alone, I will raise it to its reciprocal power. So I'm going to raise it to the 3/4, which means I'm also going to raise 16 to the 3/4, because what you do to one side, you have to do to the other. So that allows these to cancel or give me 1. So I have x on this side. And then I have 16 to the 3/4, which I can rewrite as the 4th root of 16 cubed. Now remember here, I have an even root, which means I'm going to get a plus and minus answer anytime we take an even root. So then the 4th root of 16 is plus or minus 2, and then 2 to the 3rd power is 8. So here I get plus or minus 8 as my answer. Again, we should check that both of these will make a true statement here. Really, we want to just check that this will come out to be a positive value if I put positive or negative 8 in it. So if I have 8 to the 4/3 or negative 8 to the 4/3. The cubed root of 8 is 2, and 2 to the 4th is 16. The cubed root of negative 8 is negative 2, but negative 2 to the 4th is positive 16. So since both of these end up being positive 16, I know the rest of this will work out just fine. So both of those are viable solutions. All right, for my next one, I'm going to add 2 to both sides. So then I have x to the 1/4 equals negative 2. So then to get the x by itself, I'm going to multiply by the reciprocal. So I'm multiplying by 4/1, which is really just multiplying or raising it to the 4th power. I'm sorry, raising it to the 4th power. So then negative 2 to the 4th power would give me positive 16. Right, if I multiply negative 2 together 4 times, I get positive 4 and positive 4, which would give me positive 16. What happens here, though, is if I plug in x equals 16, I have 16 to the 1/4 minus 2 equals negative 4. The 4th root of 16 is just positive 2. Right? It's different when it's plugged in. We don't have to take the plus or minus. It's when we are doing it to both sides, right? If it's already there, it's not a plus or minus answer. It's when we do it to both sides that we have to consider the positive or the negative. So since we're doing the 4th root of positive 16, my answer here is just 2. And 2 minus 2 is not negative 4, which means this is an extraneous solution, and we have no solution to this problem. All right, why don't you pause the video and go ahead. Actually, you don't need to pause the video. We are just going to try the ones on the back. Sorry about that. So if we go ahead and look at the problems on the back, when we're solving our rational exponents when it's on both sides, we're using the same method. The nice part is that there's no plus or minus here, because since you have a plus, since you have it on both sides, if you had 2 positives on one side, your answer is positive. If you have 2 negatives on both sides, if you divided by the negative, your answer would be positive as well. So there's really no, we don't have to worry as much about the plus and minus answers. We're really just going to take the reciprocal on both sides so that those exponents cancel. So looking at number 7, again, I'm going to raise both sides to its reciprocal. So 2/1. And since both of them have this fraction of 1/2, they both cancel or become 1. So then I have x plus 14 equals 2x. And then it's just the matter of solving the equation for x. So if I get x on both sides, I get x equals 14. And if I plug these in, I have 14 plus 14, which is 28 on this side, and 2 times 14, which is 28 on this side. So we would not have an extraneous solution. So go ahead and looking at number 8, we're going to do the same thing. We're going to take 2x plus 1, raise it to the 2/3 power. That will cancel both of our exponents or make them 1. So then I have 2x plus 1 equals 3x plus 4. If I go ahead and solve my equation for x, I would subtract 2x from both sides. I get 1 equals 3x plus 4. If I subtract 4, I get negative 3, which allows me to solve that x equals negative 1. So now if I plug this in, I have 2x, I have 2 times negative 1, which is negative 2 plus 1. So it's going to give me negative 1 here. And if I plug in negative 1 here, I'm going to have 3 times negative 1 plus 4, which is negative 3 plus 4, which is negative 1. So I'm taking 3 halves, negative 1 to the 3/2 power. So that's the square root of negative 1 cubed. Okay, I just made a major mistake here. Sorry. Over here, when I subtracted 2x, this is just x. Sorry about that. I don't have a very good eraser to fix it. But really, that means that I was left with x equals -3 as my answer, not -1. I apologize. These 3's should not have been there. So I didn't divide by -3, right? When I subtracted 2x, I just had 1x here. So then I had 1 equals x plus 4. So when I subtracted 4 from both sides, I had -3. So now when I plug in these -3's, really it's just going to change the value in this. I'm going to have the square root of -5 on this side. And then the square root of -5 on this side. We can't take the square root of a negative number and get a real solution, right? This would be imaginary. So then because we're not getting a real solution here, this value is extraneous and we would have no real solution. Right? This value does not give us a real answer, which means that this is not a real solution either. All right, so you can go ahead and pause the video and try number 9 and 10, or you can, I'm just going to go through them as well if you want to just keep watching. So just like we were doing, we're going to plug this in. So we have 2/5, and we're going to cancel out our exponents by raising them to the reciprocal power, which is 5/2. Again, these will cancel, so we just have x squared plus x equals 3x plus 8. So then if I subtract 3x from both sides and subtract 8, right? Anytime we see an x squared, we want to know that we're going to have to bring it all over to one side to factor. So once I bring this all over, I have x squared minus 2x minus 8, which will factor to x minus 4 times x plus 2. So x equals +4 and x equals -2. So now I want to plug these values in just to check and make sure they're not extraneous. So I have 4 squared plus 4 to the 2/5 equals 3 times 4 plus 8 to the 2/5. So I have 16 plus 4, so that's 20 to the 2/4 equals 12 plus 8, 20 to the 2/5, not fourths, sorry. So though we don't know 20 to the 2/5, it's a value, it's going to be it's the same on both sides. It would be the same decimal on both sides. So 4 is an acceptable answer. If I plug in -2, I'll have -2 squared minus 2 to the 2/5, and then 3 times -2 plus 8 to the 2/5. So here I would have 4 minus 2 is 2 to the 2/5, and -6 plus 8 is 2 to the 2/5 as well. So since both of these values, though it's not going to be a whole number, produce a decimal that we could find, they are both going to be solutions. So then the last problem, again, to get rid of our exponent, we're going to raise it to its reciprocal power, so 4/1 on both sides. So then that leaves me -2x minus 5 equals 3x plus 10. So to solve for x, I'm going to bring everything to the same side, I'll bring my x's to the same side. So then I have 5x plus 10, subtract 10, I have -15 equals 5x. So then I solve and get x equals -3. So I'll want to plug in this value to make sure that I get the same thing on both sides, and it's something we could solve for. So I'll have -2 times -3 minus 5 to the 1/4, and 3 times -3 plus 10 to the 1/4. So this would be 6 minus 5, which is 1 to the 1/4, and -9 plus 10 is also 1 to the 1/4. So I get the same value on both sides. Therefore, this is a real solution. So hopefully this helps make sense of the notes for today, and you can go on and do the practice outlined in Schoology.